Hey, I felt compelled to make a video response because you touched on a lot of points in your video that I've been meaning to make videos addressing and haven't got around to, or haven't figured out the best way to do it. And you sort of opened the door for me. And I'm not sure how long this is going to end up being, or if it's going to be several parts. I suspect it'll be several parts. First of all, on the matter of quantum physics, even though I do it myself, I feel compelled to caution against the inclination to try to apply the principles of quantum mechanics to our everyday macro life. Clearly there is a point of interface, but we don't know where that is. A lot of people like to refer to the double slit, experiment as one of the classic quantum mechanics experiments. While it's true that electrons are matter, they have weight, mass, there is a difference between electrons and ordinary matter. You can't really, under normal conditions, have a bottle of electrons the same way. For example, I have in here the element sulfur in a bottle, and as far as I know, it hasn't been demonstrated that an atomic beam, if there is even a way to make one, will pass the double slit experiment. And that's important to keep in mind. Where I think quantum mechanics can be useful is in the idea of measurement and probability. The realization that until something happens, it is in a state of probability, and once it's happened, the measurement is taken, the probabilities are all excluded except for one. I like to play around with these things just as a kind of demonstration of the principles. Six-sided dice, and you can see them or not. I like dice because they're simple and they're clean, by which I mean the past does not affect the future, which isn't true in a lot of things that we deal with in life, of course. And I want to clarify that a bit with dice. If I roll these dice for the rest of my life, chances are that eventually, from hitting the surface, as I roll these dice, there would begin to be wear on the surfaces, and at some point that would introduce a bias. So at that point, the past would be affecting the future. It would not be a clean roll every time, but under ordinary circumstances, each roll of the dice is a clean one. Now, there are 36 sides in total with these six-sided dice. 6 times 6, 36. There's exactly one way out of 36 to roll a 2, and exactly one way out of 36 to roll a 12. But there are, slippery dice. There's a total of 6 ways out of 36 to roll a 7. and so on. But you can never roll a 1, and you can never roll a 13 or above. Those are the laws of physics that apply to dice. Once you roll a number, I just rolled a 10. That's it. That's the result. That's the measurement. Before I did that, there were 36 possibilities. Having done that, there's only one. All the other possibilities or probabilities collapsed. Now, am I going to roll the dice again or not? That's a really complicated calculation. It's one that can't be made, because I don't know if I'm going to roll the dice or not. In fact, I just decided I'm not. So, see, there's a problem in trying to make these comparisons between the quantum and the macro. I'm not saying it's always wrong, I'm just saying you need to be careful about it.